Here's a KEB S4. Now yesterday I changed this SOC 23 MOSFET marking code MV. I had to remove the power board from the drive, unsoldering all the IGBTs and the three-phase bridge, and I removed the transformer that creates the isolated voltages for each of the firing channels on the output side of the opto couplers. Had to remove this to get in here. There's no room to get my soldering iron down in there. But I've got this replaced out. So I'm gonna tack the three-phase bridge onto the power board. Now I'm not going to fully solder it in, I'm just going to tack it in because I'm going to have to remove it to rebuild the drive, to put the drive back together. So let me tack that in there real quick. And we'll apply 460 volts three-phase to the bridge rectifier to power up this power board by itself with the IGBTs removed. I like to do that if I can, and that way I'll be able to measure the voltages out here without possibly shorting a probe to VCC or ground and popping that IGBT. Wouldn't want to do that. I've already got enough work to do on top of creating work for myself. Where's my solder? Come here, solder. Okay, now before I install this, I want to make sure that I have a square wave driving into the gate of that MOSFET. So let's just set that right there. I don't want to solder it all the way in because we're going to be removing that. I don't want to make it harder on myself than it is. Get a block here. Get that up in there. I'm going to just set that flush down in there, just like that, and that'll make it easier to remove than if I installed it all the way in. I'm just going to maybe solder a corner if I can. That's good right there. I need to get my close-up glasses. That. Let's put that over there. I'm going to move the camera back so y'all can see the oscilloscope when I go look at the gate signals of that SOC 23 MOSFET. Alright, we're going to apply 460 volts AC three-phase to L1, L2, and L3. Let's get that plugged in real quick. Okay, I gotta get set up here. We're gonna connect our scope's ground to probe here. Can't readily clip on ground there, but I can find it with this right here. Now here's my drawing of the circuit. this is what we're going to be looking at. This is the MOSFET that was shorted, had a hole in it. Now, I diode dropped this, putting my red lead on ground here, and my black lead around VCC ground input and output. This is not shorted. The Zener diodes are not shorted. The switching transformer primary is not opened up, so hopefully this is the only part that was bad in that circuit. We're going to look at it. So I'm going to find ground either here, here, or here, and then we're going to look at the gate, the output of the inverter driving into the gate to see if we have this waveform right here, 15 volts peak at 1 megahertz square wave. Alright, be careful, PeePaw. Don't get a hold of that 460. Okay, where are we at here? Okay, I'm not on ground. I'm turned around backwards, but we can see a square wave. Let me find ground. Let's try that one. There we are. We're on ground now. Let me spread this time out so we can look at that square wave. It's a little bit above ground, but that might be because of where I'm at. Let's go back to that one. Strange. It got all funny when I went and spread the time out. That's strange. I don't like that. I don't like the way that's above ground like that. Let's see what we got here. There we go. That's a good ground. Alright, let's spread this time out a little bit and we'll see if we can see that square wave we want to look at. Find a good ground here. There we go. There we go. Can you all see that? That looks real good. Now, I'm going to add the switching transformer onto the circuit and we'll measure the VCC and ground of each of these opto couplers. I've got to get the line turned off and unplugged from the board before I do any soldering. go. Switching transformers installed. That makes the isolated firing channel voltages. They clean up that board and we'll apply the line voltage again, and we'll measure those voltages at the VCC and ground of the opto couplers. Turn the 460 volts 3-phase on. There we go, look at that. 15 volts on that opto coupler. Let's check the next one. Whoops, slipped off. 15 volts on the second one. There's 15 volts on the third one. 4 more to check. There's the fourth one. That's good. Fifth one is good. Sixth one is good. And the seventh one is good. Alright, we can put this drive back together. And we'll be able to run a motor now. It would not run a motor because we did not have those voltages on the output side of the firing channel opto couplers. There we go. This should be good now. Give me a little while to put this thing back together. It takes some time. I got to get that 3-phase bridge rectifier off the board first. Now here's the problem with working on these drives right here. We have this piece of plastic right here, and the power devices come up through the bottom of the plastic housing through these holes right here and up into the power board that sits up on top here. So to do any kind of work on that power board, you have to take all the IGBTs off and the 3-phase bridge. Makes it a little bit aggravating to work on these things. Now before we solder these IGBTs, part number BUP313D, manufactured by Siemens, up through the plastic into the power board, we want to make sure that they're good. We don't want to put a bad device up into that drive right there and have to unsolder it again. Okay, the first thing I'm going to do is check collector to emitter. That's good. 0.402 diode drop. 0.402 diode drop. That's good. 0.402 diode drop. 0.403 diode drop. 0.402 diode drop. 0.404 diode drop. 0.401 diode drop. Collector to emitter on those IGBTs is good. Now here's a heat sink thermal that also gets soldered to the power board. That should be 0 ohms right there. That's good. And these two pins should be close to 1 kilo ohms, and they are. That's good. That heat sink thermal is good. Let's go back to diode drop and we'll check, we'll check collector to gate. That's good. That's good. That's good right there. That's good. Our collector to gate should be infinity resistance. That's good. That's good. That's good. Now let's go gate to emitter. That's good. That's good. It also should be infinity resistance. That's good. That's good. That's a good diode drop right there. .OL, that's good. That's good. Now, these 6 IGBTs run the motor. But this last one down here is for the regenerative braking circuit. Now, we also have to check our 3-phase bridge. I think this is positive. Yes, it is. Here's our AC input. Put your black lead on plus. Your red lead on the AC inputs. We have a diode drop of 0.496, 0.498, 0.490. That's good. Now let's put our red lead on minus 0.886. That's good. Now put your black lead with your red lead on minus on the AC inputs. That's 0.488. That's good. 0.488. That's good. 0.490. That's good. Our 3-phase bridge is good. We're ready to assemble this drive. Now for the hard part. Get this thing back together. Alright, the three-phase bridge, the thermal, and the IGBTs leads have all come through the power board. Time to do some soldering, but we want to make sure this is all the way flush down. Let's move that fan wire out of the way so I don't cook it with the soldering iron. There we go. The hard part is done. Let's get the rest of that drive back together. These are the current sense we're going to solder onto the drive. Careful not to melt the plastic. It's real easy to do. All right. There it is, minus the cover. Let's fire it up and see what it does. Let's make sure we ain't got no short circuits. Red lead on 3-phase bridge ground. Black lead on L1. 0.486, L2, 0.488, L3, 0.487, U, 0.398, V, 0.399, W, 0.399, all that's good. Put your black lead on 3-phase bridge plus. Red lead on L1, 0.495. L2, 0.488. L3, 0.496. That's good. U, 0.419. V, 0.418. W, 0.418. All that's good. Let's jump out our motor thermal. So we don't get a motor thermal alarm, just take a piece of jumper wire and jump these OH terminals over here. Let's bring our line voltage in. We ain't powered up yet, so we're not going to get shocked. Not yet, anyways. All right. There's L1. L2. There's L3. Now, the jumper wire up here on the terminal 1 on the S4 is control release. That's your master enable. Terminal 10 is plus 24 out from the drive, and you apply that to terminal 1 to enable the drive. Let's fire this thing up. Get plugged into the wall. Alright folks, hold on to your farm animals. Here we go. There we go. Alright, good deal. We fixed it. Let's go and I'll hook up the RS-232 panel, and we'll set the drive to drive mode, and we'll run the servo motor on it. Right now we're getting an encoder fault because I don't have the servo motor's encoder plugged in. Okay, I'm going to power it down. We'll get set up to run in drive mode. This panel has an RS-232 port that allows us to talk to the CombiViz program. Let's go over to the laptop and we'll open up the CombiViz program. Click on the KEB CombiViz icon. Now right now it's hunting for that drive. Let's get closer and you can see that. If it finds it, it will open up the parameter listing. There it is. That took a while, didn't it? Did y'all go get a cup of coffee while you were waiting for that? We're going to set this drive to run that servo motor from the keypad. It's called drive mode. Now, in order to do that, we have to get it out of CAN bus mode. So we go to UD, group parameters, and go over here to UD05. Let me get you closer so you can read that. Now, right now, parameter UD05, control word activate, is set to 1. Control word active. That means that that drive is commanded to run through the CAN bus. We want to run it from the keypad. So let's go up here, double click on that, and you'll see a drop down menu. Now we go to this drop down menu right here, and we select 0, control word not active. Now we'll be able to run that drive from the keypad after we set it into drive mode. Almost power down and swap out that keypad. The 7-segment display on this other panel right here is a little bit brighter. You'll be able to see it a little bit better, what we're doing. Okay. Now you can see that decimal point right there is blinking in the group parameters. That means that we can change the groups. Now we went to UD0, and right now this shows us we're in application mode. That allows us to look at all the parameters with the keypad. From here, press the up arrow until you reach the value of 500. Oh, went too far. Back up. Now press enter. Now we're in drive mode. We can run from the keypad. We have to have, let me back up a little bit and I'll show you this. In order to run, we have to have terminal 10 on this S4 jump to terminal 1. That's your control release terminal. You apply 24 volts DC from terminal 10 up to 1, and that will allow us to run. That's like a master enable. To run the drive, let's get back closer to the keypad. We want to press start. You'll see a 0. Press start again, and now that motor is running. To stop, press the stop key. Press the stop key again, and it'll go back to LS. When you see LS in the keypad there, that means you're ready to go. You're ready to run. Press start. Press start again. Now, if you wanted to speed up, let's stop real quick. If you wanted to speed up, you press the speed button and hold it, and you can increase the revolutions per minute with the up arrow key. You can decrease the revolutions per minute with the down arrow key. Let's go over and watch that motor run. Let's speed it up. You can speed it up on the fly while it's running. There we go. We got 369, 370 revolutions per minute there. We can slow it down on the fly. There's 161 revolutions per minute. Isn't that neat? Well, now, before we changed out that surface mount MOSFET that was driving into the switching transformer, making the isolated firing voltages on the output side of those opto couplers, this drive would not run. We fixed another one. All right. Good job, folks. Good job. Now, when I get done running this servo motor and servo drive, I'll set that UD05 parameter back to 1 so that this drive will operate off of the CAN bus. Let me show you the CAN bus module. Right here's the CAN bus module. It plugs into the same place as that panel over there with the 7-segment displays, and it communicates through this connector right here. Isn't that fascinating that you can run this drive through a port like that? That is amazing. There we go, folks. Hope you're having a good day. We're doing all right here. Doing much better after we fixed that drive right there. That was a bear to fix. Shoo-wee. Thank you very much for stopping by and helping out on that job right there. We'll see you next time. Hey, welcome back. I forgot to mention how to get out of drive mode. So let's stop the motor. We see LS in the screen. Press the enter and function keys. Hold them both for about 3 seconds. There we go. We're out of drive mode and we're back in application mode. Sorry about that. That's pretty important. It won't run in CAN bus if we're still in drive mode. All right. We'll see you again.